Hey guys, welcome to question MM396 of the Maths Methods Fortify study guide. So, in this question we've got Troy goes to the gym every day in the winter in an attempt to get huge. The amount of time he spends training each day is a continuous random variable x hours with probability density function given by this. So f of x equals 1 on 9, x cubed on 3, take 5x squared plus 6x between 1 and 3. Now, part A is a 1-mark question and says, on any given day in winter, how much time is Troy expected to spend at the gym? Give your answer correct to 2 decimal places. Awesome. So, whenever we talk about expected value, or how much time is he expected to spend, that's exactly what we're talking about, our expected value, which is our mean. Okay? And in a continuous probability function, to find our mean, we take our integral from our lower to our upper, and we do x times f of x inside that function. So, because this is a 1-mark question, all we need to do is fill in the blanks here, and then put that into our CAS, and we'll get our answer. Okay, so our lower and upper are 1 and 3, x times f of x, which is our function here. So times 1 on 9, x cubed over 3, take 5x squared over 2 plus 6x dx. Now again, it's a 1-mark question, so plugging this into your calculator will give you an expected value of 2.01 hours. That's correct to 2 decimal places, and that is our first and final mark for part A, and that's it. So let's move on to part B. Part B is a 2-mark question and says, on any given day in winter, Troy has a 43% chance to spend more than n hours at the gym. Find the value of n correct to 2 decimal places. Awesome. So again, with probability density functions, our probability is always dealing with the area under our graph. Okay, so if we have a 43% chance to spend more than n hours, that means that our probability that we spend more than n hours is 0.43, right? Because 43% is the same as 0.43. Now, again, our probability is the area under our graph. Okay, so the area under our graph after n hours, right, is 0.43. So our area, 0.43, of our integral from n to our upper bound, which is 3, so more than n is from n to our maximum, 3, of 1 on 9, x cubed on 3, take 5x squared over 2 plus 6x dx. And this is our setup equation, right? Now, what we're going to do from here is we're actually going to take this 1 on 9 out the front here, 1 on 9, because it's a constant, so we can do that. And then what we're going to do is multiply both sides by 9, right? To get rid of that 1 on 9, and we can multiply that across. So what we get is 3.87. And now we can actually integrate this as normal. So what we get is x to the power of 4 over 12, take 5x cubed over 6, plus 3x squared from n to 3. That's our first mark, right? So out of these 2 marks, that's our first one. And now we can actually sub in as normal. So what we need to do is sub in our 3. So we get 3.87 equals 3 to the power of 4 over 12, take 5, 3 to the power of 3 over 6, plus 3 squared, minus, so that's all in brackets, minus, and then we sub in our n. So n to the power of 4 on 12, take 5, n to the power of 3 on 6, plus 3n squared. And then we can just solve this as we go. So merging all of this stuff together, which you can do in your CAS, what you get is 0 equals n to the power of 4 on 12 minus 5n cubed on 6 plus 3n squared takes 7.38. Now, according to our CAS, we can plug this in and solve it, and we get n equals negative 1.32 or n equals 2.15. Now, because our value of n has to be within our domain, between 1 and 3, n equals 2.15 is our answer. So you would say n has to be between 1 and 3, so therefore n equals 2.15 hours. This is our second and final mark for part B, guys. And that's it. So if you have any questions, let me know. But let's move on to part C. Part C changes pace here. So we're actually moving away from our function, and we're moving towards conditional probability. So part CI is a 1-mark question, and says, during the summer, Troy does not go to the gym every day. If he goes one day, the probability that he goes the following day is 1/2. Okay, so actually let's get rid of this. So if he goes, then he has a 1/2 chance to go the next day. If he doesn't go, he has a 1/4 chance to not go. Awesome. He goes to the gym on a particular Wednesday. What is the probability that he will go to the gym on all of the following 3 days? All right, awesome. So if he goes to the gym on the Wednesday, that means that he's got a 1/2 chance to go on the Thursday, on the next day. So 1/2 Thursday. So he's gone on that day, right? Then because he's gone on this day, the chance that he goes on the Friday is also 1/2, right? Friday. Then because he's gone on the Friday, the chance that he goes on the Saturday is also 1/2, right? Because he's gone, so he has a 1/2 chance to go, then he's already gone again, so 1/2 and 1/2. So the chance that he or the probability that he goes to the gym on all of the following 3 days, so Thursday, Friday, Saturday, is 1/2 times 1/2 times 1/2. So probability that, I don't know, all 3. And probability is really loose in this way. Like, you don't have to be super concise with the syntax that you use inside your probability brackets. As long as the person reading it knows what you're saying, then it's all good. Equals 1/2 times 1/2 times 1/2, which equals 1/8. And that's our first and final mark for part CI. Let's move on to part CII. CII is a 2-mark question and says, what's the probability that he doesn't go to the gym on the following Friday? All right, awesome. So what we're going to need to do here is draw a tree diagram, okay? Because we've got multiple pathways that we can take to not going to the gym on the Friday, all right? So on the Wednesday, we know that he goes, right? The question tells us that. So then on the Thursday, we have the option to go or not go, okay? So that's our Thursday. Then on the Friday, we also have the possibility to go or not go. Awesome. So this is the Friday, and what we're looking for is the probability that he doesn't go on the Friday. Okay, so we're looking for this path here where he goes Thursday and doesn't go Friday, and also where he doesn't go Thursday but also doesn't go Friday. Okay, so on the Wednesday he's gone to the gym, which means the probability that he goes to the gym on Thursday is 1/2. Which means that the probability that he doesn't go to the gym on Thursday is also 1/2, because these two have to add to 1. Now on the Thursday, the probability that he goes on Friday is 1/2 again, right? Because he's gone, so he's got a 1/2 chance to go on the next day. And again, that means he has a 1/2 chance to not go. Now, but because he hasn't gone on the Thursday, he's got a 1/4 chance to not go, right? So that means that because he hasn't gone here, he has a 1/4 chance to not go here, which means that he has a 3/4 chance to actually go, because these two have to add to 1 again. Now, we want the pathway that we have G, G, not G, and G, not G, not G, right? Because they're the pathways that will end up in him not going on Friday. So the probability that he doesn't go on Friday is equal to this branch, so the probability of G, G dash, and this branch, plus probability of G dash, G dash, right? Now, the probability of this pathway here is our branch times our branch probability. So 1/2 times 1/2 plus 1/2 times 1/4. What this gives us is 1/4 plus 1/8, which is 3/8. Now our tree diagram gives us our first, that's not 1, gives us our first mark, and our answer gives us our second mark. So the probability that he doesn't go to the gym on the Friday is 3/8. Guys, that's it for part CII. Let's move on to the next one. Part CII is, again, dealing with our conditional probability and our tree diagram, but we're going a little bit deeper this time into a given formula. So this question says, what's the probability that he goes to the gym on Thursday, given that he doesn't go on Friday? Okay, so what we're looking for is him going on Thursday, given that he doesn't go on Friday, so doesn't go on the Friday. Okay, so according to our given formula, or our conditional probability formula, probability of A given B equals the probability of A intersect B over probability of B. Awesome. Which means that our probability of G or he goes on Thursday, given that he doesn't go on Friday, is the probability that he goes on Thursday intersect, where he doesn't go on Friday, over the probability that he doesn't go on Friday. Awesome. So this is our first mark. So finding that is that mark 1. Now, we're looking for the probability of the intersection between him going on Thursday and him not going on Friday, okay? So the way that we figure this out, especially with a tree, or specifically with a tree diagram, is we want him to go on Thursday, so here, and we want him to not go on Friday, so here, right? So the intersect between these two is this path, so 1/2 times 1/2, over the probability that he doesn't go on Friday. Now, we found in the previous question that the probability that he doesn't go on Friday was 3 on 8. And that's exactly what this is. So we found that the probability doesn't go on Friday, 3 on 8, so 3 on 8 goes on the bottom here. So what we end up with is 1/4 over 3 on 8, which gives us 2 over 3. So the probability that he goes Thursday, given that he doesn't go Friday, is 2 on 3. So that's our final answer for CIII, guys. Let's move on to part D. Part D says Troy starts working on his powerlifting and is using very heavy weights. On any given attempt for a power lift, the probability that he successfully lifts the weight is 7 on 20. Assume that the success of any lift is completely independent of any other lift. All right, so that's really important. In a set of 12 attempts, what is the probability that he completes no successful attempts? All right, awesome. So this is just a 1-mark question. And we immediately need to recognize that we're dealing with binomial distribution here, right? So the reason we know that, as I've said in multiple questions before this, is each attempt has the same probability and is independent of any other attempt, and there's also a success or a failure, okay? So there's only 2 outcomes with this. He can successfully lift the weight, or he doesn't successfully lift the weight. There's no other possibility of outcome. So that's how we know it's a binomial distribution, okay? So what we're looking for is the probability that he completes no successful lifts, okay? So the probability that, let's let our lifts equal x, so our lifts equal 0, right? So no successful lifts. And that's what we're looking for. So what we can do is use our binomial, because this is a 1-mark question, we don't have to show any working. We can use our binomial PDF calculator in our CAS. So I think that's menu 55D for me. So menu 55D. And that'll get you to Binomial Pdf. And what that does is calculates this for you. So it'll ask you for n, p, and x. N is our number of trials, or our number of attempts. In this case, it's 12. The question tells us that. The probability that he lifts a weight is 7 on 20. And what x value we're looking for is the number of successful attempts, or the number of successful lifts in this case. What we're looking for is 0 successful lifts. So we type in 0, click enter, and it will give you the probability that x equals 0 is equal to 0.0057. And that's your first and only mark for DI. That's it. If you have any questions about how to use this on your CAS or anything like that, just hit me up. But let's move on to part DII. So DII is very similar to this, but we're going to be using a range of values as opposed to just one value. So this is a 2-mark question, and it says, what's the probability that he completes more than 5 successful lifts? Right, awesome. So whenever we're dealing with a range of values with binomial, we need to use our Binomial Cdf calculator, which is menu 55E, for me at least. Now it's going to ask you for multiple things. It's going to ask you for a lower bound, an upper bound, an n value, and a p value. Okay, so we're looking for the probability that he completes more than 5 successful lifts. So the fact that x is greater than 5. Okay, so if he's completing more than 5 successful lifts, that means that out of the 12, he can complete 6, 7, 8, 9, 10, 11, or 12, right? He can't complete 5 because that's not part of this greater than 5, right? Because 5 is not greater than 5, so we're not dealing with 5, which means that our lower is 6 and our upper is 12. So lower is 6, upper is 12. n is the number of trials or number of attempts, which in this case again is 12, and our p-value is the probability of success, which is again 7 on 20. So from here, we simply click enter in our CAS. This is our first mark, by the way. We click enter, and therefore we get probability of x, that x is greater than 5, equals 0.2127. And this is our final answer for part DII. So that's our second mark and final mark. That's it. If you have any questions, as always, let me know. But let's move on to part E for now. Part E is a 3-mark question. Or part EI is, I should say. And it says, Troy enters a strength competition in which he must complete 200 attempts at a power lift over the course of a day. Troy does his first 20 attempts and uses the results from this sample set to estimate what his overall results will be. For this sample set, p hat is the random variable of the distribution of sample proportions of successful lift attempts, and we need to find the probability that p hat is less than or equal to 3 on 10, given that p hat is greater than or equal to 1 on 10. Awesome. Give your answer to 4 decimal places, do not use a normal approximation. Alright, sweet. So the first thing to do here, whenever you see a question like this, we want to convert this p hat into an x value, okay? So we want to treat this as a binomial distribution, but we can't do that because at the moment we're dealing with proportions as opposed to exact values. So what we want to do is convert these p hats into exact values. So we know that p hat is given by x over n, right? Where x is your successful attempts or your successful proportion over your total sample space, right? So if p hat is equal to 3 on 10, just dealing with this one now, if p hat is 3 on 10, that's equal to x, which is what we're looking for, over our total attempts, right, which is our 20 attempts. That means that x is going to be equal to 6, and when p hat equals 1 on 10, that's equal to x over n, which is 20, which means that x is equal to 2, right? So that means that this is the same as the probability that x is less than or equal to 6, given that x is greater than or equal to 2, right? So this is our first mark. Now, this is now a normal, sorry, I shouldn't say normal, this is now a usual conditional probability given formula, which means that this can be rewritten as probability that x is less than or equal to 6 intersect x is greater than or equal to 2 over the probability that x is greater than or equal to 2. Alright, awesome. Now let's just take this one step further and combine this intersect, which means that we have 2, x, and 6 over probabilities x is greater than 2. Sweet. So now we have to find our individual probabilities of these using our Binomial Cdf. Okay, so we know that every lift has a 7 in 20 chance to be successful, right? So we're still dealing with binomial distribution. Even though we're dealing with stats now, we're still dealing with that binomial kind of system. So what we get is, well, we need to figure this one out first, then we can figure this one out. So between 2 and 6, we pull up our Binomial Cdf. Our lower is 2, upper is 6, n again is 20, because we've done 20 first 20 attempts, and p again is 7 on 20, because he still has that same probability to get each one right. So therefore, the probability that x is between 2 and 6 is equal to 0.4145. And then we can figure out this one. So the lower this time is 2, and our upper is 20, right? Because we don't have an upper limit for this because it's greater than 2, but we have a natural upper limit because we've only done 20 trials, so we can't figure out the probability of doing 21 because that's not in the domain. So then our n is again 20, and our p is again 7 on 20. Awesome. So plugging this into your CAS, you therefore get probability that x is greater than or equal to 2 is equal to 0.9979, almost 1. Now, there's our second mark right here. So what we can now say, actually I didn't really need to do that. What we can now say is that this probability is this, and this probability is this. So we can say that this is equal to 0.4145 over 0.9979. Plugging this into our CAS, we get 0.4154. So therefore, the probability of this, so the probability that p hat is less than or equal to 3 on 10, given that p hat is greater than or equal to 1 on 10, is equal to 0.4154. Now this is our third and final mark for this part, guys. If you have any questions about converting this into binomial or using this binomial or anything like that, chuck them in the comments below and I'll answer them as soon as I can. But for now, let's move on to part EII. Part EII immediately starts dealing with confidence intervals, which you might have seen before. Let's get rid of all this. Part EII. This is 1 mark, so you don't have to do any working for this. You just need to say your answer. You will obviously need to do working to get to the answer, but that's fine. So we're trying to find a confidence interval now. Okay, so we know that our confidence interval formula is given by p hat minus z root p hat 1 minus p hat over n, and then p hat plus z p hat 1 minus p hat over n. Now, because this is only 1 mark, we can actually use a really cool shortcut in our calculator to find this. All right? Now, we can go through this whole process and do it manually, which I will actually show you how to do after I show you how to do this calculator bit. But with the calculator, all you need to do is go to Menu, Statistics, so number 6 in my case, then down to Confidence Intervals, and then down to 1 prop Z interval. All right, so mine's number 5 here, so 665. Click on that. Now our successes, it tells us that he completes 6 successful lifts in his first sample of 20. So we're looking for a 95% confidence interval, corrected 3 decimal places. He successfully completes 6 lifts, so successes is 6. His number of trials that he does, his number of attempts, is 20, and we're looking for a 95% confidence interval. So what we do in the CAS is type our successes, which is 6, we type our n value, which in this case is 20, and our confidence level is 0.95, which is exactly what we want. That's our 95%, and then we click enter, and our C lower and our C upper is our confidence interval. Okay, so our C lower here says 0.099, and our upper says 0.501. That's correct to 3 decimal places. And this is our first and only mark, guys. So if you've got a 1 mark question or a multi-choice even, I would highly recommend doing this in your CAS. So it's, menu 665 in my CAS. So it looks something like that. Alrighty, that's it for part EII, and that actually wraps up MM396. So guys, if you have any questions about any of that, please let me know in the comments below. But otherwise, thank you for watching and have an awesome day.